Welcome to my 6th video in our Unity FPS series. And in this video, we should try to wrap up with the world building component of this project. And so the goal for this video is to build a really quick interior level and then set up triggers so that we can transition between indoor and outdoor levels. So let's get to it. So right now, the top priority is we need to turn the player into a prefab, because we're going to want to have the player, the same exact structure we have for the player spawn on the interior level without having to reconstruct it from scratch. And then additionally, we'll want to kind of offload that into a game manager object, which will handle the spawning of the player for us, so that it'll just track the prefab and spawn as needed. So with that, we'll need to create a new folder here for prefabs. So we're going to right click on assets and go to create folder. And this is going to be called prefabs. Inside of there, I'm going to create another subfolder for player, for anything relating to the player, and double click that. Then I'm going to drag and drop the player object from my world into the project down here, and that will automatically create a prefab for it. So now I can spawn a player whenever I need to. And now the player doesn't really have much in terms of graphics, so it just appears like a blank box, but I can drag and drop this into a new level. And that's the key thing here. So let's save our scene and create a new scene for where we're going to go. So in the scenes folder, this is currently called sample scene. I could rename this to something like overworld, because this is my overworld map. And I could create a new one. So I'm going to right click and create a new scene. And I'm going to call it mine or dungeon or cave. So pick a name that you want to design. I guess I'll call it cave. It's not really a cave, it's kind of more of a little mausoleum thing, but don't worry about that. So we have our new level. Now what's going to happen is when we double click this, make sure this is saved, this is all going to go away. And we now have a blank level to work with. So I want to put a little bit of a stage in here. So you could make this out of just, 3D blocks. You could make a few cubes, reset the transform to 0, 0, 0. Gotta find where that even is. And you could just reshape blocks in the size of a level if you wanted to make the interior. But I have some assets, and you can very easily find some assets that will work for interior environments. So the way that I'm going to construct this is essentially a modular building set here. So I have different pieces of terrain that I could use. So I could just take a bunch of tiles and bring them in. And then when working with this, it is actually best to kind of try to stay on a grid, because many modular systems are set up to be grid-like. So whenever I bring this other tile in and reset it, if I hold Control, it snaps to some level of gridness. And we can see that actually, each one of these tiles is 5 by 5. So if I was constructing something out of all of these, 5 by 5 would be kind of the size that I would be working with. And I could put all kinds of other things in there to create a more interesting setup. And we could even make the grid snapping a little bit more consistent, I suppose. So if you wanted to find that stuff, so I'm checking preferences first. If I type in grid, grid, I see that there's a mention of that, but nothing about like actual grid line size. So maybe I would check project settings and search for the grid here. Don't find it there. That might be under one of these settings. Ah, here it is. So here's our grid visual. If we wanted to change some of this, so here's the snapping increment. So we could try to make it every 1 unit, make the grid on a scale of 5. And so when I move this, it's moving every 1 increment. And I would assume if I move, no, that's not snapping. But it could make it easier for me to set up these tiles. And that's likely to be true of the walls as well. So as I start putting walls in, now I don't need walls that I can see both sides. So like some of these walls actually only have texturing on one side. So whenever I bring in a wall and I want to place it, and I'm holding down Control to keep as much snapping and right angles as I can, then I can construct my walls as I see fit. So with this, maybe I don't want to use snapping. Maybe I just want to manually align it. Just kind of depends on the circumstance. So let me just quickly throw together just something for the player to stand on so that we can have something for them to use. And naturally for an interior, you would spend a decent amount of time working on lighting, kind of creating a more interesting tunnel. So I'm just trying to get some walls down and then be able to set up the scripts to transition between the two. So I've got a small tunnel, and maybe I'll put a quick roof on it. I forget where roofs are. Perhaps under walls, ceilings. Yeah. That piece. So we could use something like this. So now keep in mind that the view angle of something does actually matter because some textures, the way that the UVs are mapped, it's not visible from a side that's not meant to be visible from. So a quick little tunnel for the player to stand in. And I'm even going to drop the player prefab in here that we just created. So inside of my prefabs, I can place my player. I'm going to pull him up so he's not going to fall through the world. And maybe rotate the player. Well, that's fine. So when I hit play, it's going to play test this level. Oops, I accidentally have 2 cameras still in the scene. The default main camera from the default scene was still there. And so that interfered with the player's ability to exist. So, you know, here's the player inside this scene. We can imagine that I've actually constructed out a full dungeon. I've got the lighting set up right. So you would kind of go through and modularly piece through a dungeon. The other alternative would be to design entire rooms inside of a 3D tool and then have just kind of place them as an entire set piece, which is how some games do it. It makes the level design a little bit easier but less flexible. And there are script and tools that could procedurally build some of these things and make this work a little bit better. I would have to take out the directional light to fix some of this shadowing because that's a light just coming from that skybox area is making this look a little bit ugly. But we still have an interior. And I could place an exit item so that I can start moving between the worlds. But at this point, we're going to need to start really working off of the idea of spawn points, because whenever the player, we don't want to just create a bunch of maps that have a player object here, because starting the level like right here doesn't really make sense. Like, where did we come from? So we're going to need to start moving away from pre-placing the player and then using like a spawn point system. So whenever the level loads, depending on where we came from, we spawn in at that spawn point. So I'm going to create an exit here. Wonder if I have any good doors that might work for that. And of course, as you build your level, you could even use walls with doors and use what we did in the previous videos to be able to create places like actual doors that open when you use them. So you'd be able to put together a kind of interesting level using the skills that we've built up to this point. So, where's a door? I guess we could just use one of these. So that will be our activatable object that brings us out of the dungeon. So we can just press use on this, and much like kind of like a Skyrim-esque game, we could we would be able to animate the door and just like load the next level immediately, because that's really what those games are doing. Is that they're just, you know, the door animates, and then it was just some kind of trigger to trigger a new scene load. All right, so we've got our piece there, and we're beginning to have all we need to transition between the stages. So let me fix this error real quick when we get window failed to load. You can just do layouts, reset layouts, and that brings us back and should prevent that from popping up in the future. Yeah, so I'm not getting that error down there anymore. Okay, so let's create a script. And actually, let's go back to the other stage. So make sure you save your scene. And we're going to go back to the overworld real quick. And let's begin creating the game manager as well as the spawn point system so that we can start transitioning between these stages. So I'm going to start with the game manager, which is going to be responsible for spawning the player. And it's going to be kind of our repository for information that needs to persist between levels, which, such as where we came from and which spawn point to use, is going to be stored on there. So for that, I'm probably just going to create a folder. Let's call it manager. Anything that deals with managing stuff is going to go into there. So we're going to create a new C# script called game manager, and double click that to begin working on it. And I'm going to then create an empty game object inside of Unity, and I'm going to rename this to game manager. I'm going to reset its transform to be something kind of normal, like 0, 0, 0. And there is a game controller tag, and I am going to give it the game controller tag just in case we need to find it with a tag. That's really what that tag is for. So it doesn't need to necessarily be on a specific layer, but it doesn't have anything here, so it's fine if it's on default. And then I'm going to take this script that doesn't have anything yet and just attach it to the object so that at least we have it attached here. Okay, so now let's begin setting up our game manager. So the first thing that we're going to create is a global, essentially a global variable that we can use to reference this object. So that's going to be public static, and you can actually see the autocomplete kind of guessing where I'm going with this. Game manager instance, except for I'm going to use the, I believe it's called properties, where I can kind of make it so that it is public to get it, because this is just going to inherit that public, but it's private to set it. And if you remember your object-oriented programming, being private to set means that only the game manager can replace this value. So you can't like accidentally delete the global variable that's going to reference everything that's inside of our game. So this is a global variable. Essentially, you would say game manager dot instance dot whatever to get the information that we need out of this. And then accessing it is public, but setting it is private, so you can't accidentally delete it. So then all of my instance variables here. So we'll start with some things that we actually have to required, I don't know, we'll call this required settings. And we will start with the prefab for the player object. And we'll call this required prefabs. And so we would need to define that at some point. So then we have a header for game state variables. So these are variables, things that we might need to remember during the play of the game. So for example, maybe we have a player hit point max that needs to be something, and then we have a player hit points. And then we might need a spawn location. And that's going to be used in between level loads to know which spawn name to spawn from. And then a private variable called isInitialized that we'll use to know if we've if we've kind of set this up yet. Okay, so this is a little bit of magic here. So this is going to be an interesting object in the sense that it's not going to be deleted in between scene loads. So this is the first time that we are likely to see this. This is a kind of neat, I guess a neat little trick that Unity can do. So we'll do this in the awake method rather than the start. And instance is going to start null. So we could obviously say if instance is null, then we want to track this thing. We can say instance equal this. And then we can prevent it from being destroyed. So that command is called don't destroy on load. And then we pass it the game object. And then some other things. So we could put a listener for when a new scene is loaded. So that would be scene manager dots. And that actually should automatically add a new import up here. So if it didn't automatically add a new import, you do need unity.scene management. So scene manager dot scene loaded plus equals. And then this is going to be the name of the method that we create ourselves, on scene loaded. And that's just and it's mad right now because we haven't defined that method. And then we'll call the method for any sort of initializations that need to happen. And so I guess we don't have that method yet, so we'll need to write that. So let's start making some of this code happy. So let's create that onScene loaded method. And it's going to automatically want to pass some parameters to us. So we want scene, comma, scene. Oh, I'm sorry, scene, comma, load scene mode. There are a couple different ways that scenes get loaded. That just gives us information about the way that the scene got loaded. Because there's like replace and then there's additive where a scene loads in addition to what's currently there. So we have our method for that will get triggered whenever a new scene loads. Well, we will come back to flesh that out in a second. Let's make our initialize game. Whoop, not on server initialized. So initialize game, and then we'll call it right here. So initialize game is going to be a method that we'll just use to do some things. Like, for example, I'll set my hit points to my max. So there might be things over the course of this project that we'll want to add to this, but right now, so we'll just say player hit points equal player hit points max. That's really about it. Maybe this could be giving the player a weapon to start, giving them some initial ammo, just some things that the game might need to trigger. and so that we only run this once. Then, because we've attached a listener here, we do also need to memory manage that ourselves. So there has to be an onDestroy method where we unattach from the scene manager scene loaded, on scene loaded. So this is so on deletion, we want to take this off of the scene manager. Otherwise, it will stay there, and if this gets deleted, then there's no method to call anymore. All right, so getting there. The only other thing left is going to deal with spawning the player. But since we haven't written a script to hold the information about a player spawn, we really can't finish that. So I'm going to go back up to awake and do one more thing. Else, if instance is not equal to this, then destroy this game object. So what this is going to do, this is kind of a clever way to only ever have one copy of the game manager. Because the map that it was placed in, this overworld map, we can transition back to it. So when we go into the cave, when we come out of the cave, we're going to reload the overworld. And inside that world will be another game manager. But we want to keep the original one. We don't want the new one. So this code will delete the new game manager because that's going to load when we load this level back in. And we only want one copy of this thing. So that's it, except for the scene loaded code. We're going to need to come back to that in a second. So we'll hit save on this. And you should see that that updates here in the game manager object. There's nothing we really need to play with here. Well, actually, we do need to attach the player prefab. So we're going to take this player prefab and attach it to there, because that's going to be the object that we spawn whenever a scene is loaded. So inside of the manager, or we could probably put this inside of player, we need a script for a spawn point. So I'm going to create a new C# script called player spawn point. And a player spawn point doesn't need a whole lot of information. All I want with this is just an ID. So we'll call this spawn point ID. And I'll start empty. So that we can attach this script onto a spawn point, and then we can see what the tag for a given spawn point. I didn't want to call it tag because tag is a specific thing. So I'm just going to call it an ID. So now that this class exists, we can go back to Game Manager and finish that up. So we can finish up this on scene loaded, and we can finish that by creating a spawn player method. So maybe we'll we'll keep it private for now. If we need to access it from outside this class, we'll think of how we'll deal with that. So spawn player. And when we spawn it, we're going to use a specific tag to search for. So we'll call this spawn ID. So the spawn ID is what we're looking for. When this method gets called. So we are going to grab a list of player. So we'll just call this like possible player, slipping into like Python naming here. Possible player spawn points. And we're going to use the command gameObject. Find game objects with, you want the plural one, game objects with tag. And so we're going to need to tag them as player spawn. So it's a really long variable name, but so we'll do a for each loop where we loop through each of these game objects. So for each game object temporarily called spawner in possible player spawn points, if that spawner dot get components. So one of the things that we need to make sure is that if something is tagged as a player spawn, it must have the script player spawn point, otherwise we would crash. Because we're not really doing a null check here. I mean, we could. Is not equal to null and spawner.getComponent dot spawn point ID equals spawn ID. So it might be better to just clean this up. So we can make sure that if the script is not equal to null, like that. So if that's the case, there we go. So spawn point script, we grab it as a thing. And so if the spawn point script is not equal to null, and the spawn point script's ID is equal to this spawn ID that's coming in as a parameter, then we will actually instantiate a player. So the spawner's rotation is going to matter because we're going to inherit the rotation for the player as well. And then we'll break out of this loop so that the loop will stop. So then all we've got to do is just call spawn player, passing it in spawn location. So we call the spawn player method. This variable is going to get written over by the spawners. Whenever the player is exiting a level, this is going to change. So when we call spawn player, it's going to have a different value. And that's it for now for the game manager script. So I'm going to save that. And now this is going to mean we need to put a spawn for the player, because what's going to happen right now is it's going to look to spawn a player. So when we go back to Unity, we need to make a player spawn point thing. So we're going to create an empty, and I'll call this player spawn point. Now we need the tag that we said we were going to use. The tag that we said we were going to use is player spawn. Now we go back to here and then reassign it. And then we can attach that script we just created, the player spawn script. And its name is currently blank. We'll leave that blank for now. And we're going to turn this into a prefab, so that I can just drag and drop these into the world so that we can spawn a little bit easier. One of the things that could be kind of problematic is the height of them. So it may be worth revisiting putting like a, I don't know, like a collider that's deactivated or something, so that when we drag them into the world, they spawn at the correct height and we don't have to manually set a height. So, but that's something we can play with later. So I'm going to bring this down as a prefab with my player. So now I have a player spawn point. So I can delete that. I can then put a player spawn point. And actually, since it's invisible, that is a little bit annoying. I do want to give it like a Unity label. So when I'm just editing the prefab, I'm just choosing some kind of icon for it. So I'm going to bring a player spawn point in here. And remember, the rotation of it matters. So the player is going to be facing in the positive Z axis. So the player will be facing this direction when they spawn. And if we want to make sure that the collider looks good, going over here, I do want to add a, let's create an empty child. Oops, actually, no, we don't want to do that. We want to add a capsule. And this capsule, I'm going to reset its position. And I want the capsule to be the same height as the player. So I'm going to set this to 1.6. And I'm going to also reset this position back down to 0. With the thought process that whenever I want to drag and drop this into the world, I could see the spawn, and then I could just turn off the mesh renderer. So for example, now my spawn point looks like this little capsule, but that's okay. The player is going to be that size when the player spawns in, because the player is 1.7. So maybe we need to go make my capsule 1.7 tall. And so that's going to be a spawn point for the player. Perhaps that is a little bit too tall. Yeah, you could play with some of these settings. Maybe I need to divide that by 2. Yeah. And then that should accurately, yeah, encapsulate the player's height. And then once I place it, I can just hide this capsule. So now I can delete the player, and you know, I don't have any cameras. There should be no cameras in the scene, but when I hit play, after I fix my compile errors, when I hit play, it should instantiate the player in there. It might have cleared that. Interesting. Player spawn. Oh, it doesn't have the tag. So we need to match this to say start, because it's looking for a player spawn that says start to spawn in the player. And then so we get spawned in. We're able to do all of our usual things. And now we've got a spawn system working. So wherever we place this player spawn is going to be where the player shows up. And the rotation will matter. So the direction it's rotating, the player is going to come in facing that. All right, so now we can turn our focus to getting the connectivity between the levels working. And this is the important part. This is the part where we can go between levels. And it's really, the hard work was getting the spawning system to work. This is going to be a lot easier. So to achieve this, we're going to need one more script, put it under objects. This will be a new C# script. And I'll call it activate exit. And so this script, we will do our settings here. So I do want to steal some parts, but I can also write some from scratch. So I'm going to jump over to Fire real quick, and I'm going to take these two parts, the header, the general settings, and the tooltip. So I just don't want to have to rewrite those. And so when we activate this, the tooltip that we should see, and we'll actually do this in probably the first video of the next chapter, enter cave, and it's never going to be deactivated because entering the cave transitions the level. So some simple maintenance here. So we've got our getName method we have to implement, and that's going to return the activate message. Let's not forget to inherit from iActivate. Public Boolean ready will return is ready. And you could tweak this and make this not ready or not ready to activate, depending on how you want to set things up. And so the meat of this is going to be in the activate method. This is where we're going to load the next level. So we're going to do public void activates, and we're going to call game manager dot instance dot spawn location, and we'll call this from overworld. And that's the name of the spawn that it's going to look for in the new map. So matching that string exactly, if we want to use an underscore instead of a space for clarity, maybe we would. But it's going to match on a string, so it's just string equality. And then the scene manager stuff. So scene manager dot load scene. And here's the easy part. We just put the name of whatever it was called inside of our scenes. So I called it cave, so I do capital C cave. We don't worry about the file extension. The file extension is cave.unity, but we're just going to do cave as a string. Then hit save. Now there's going to be one thing we have to set up in the project settings to get the scene to load. We can reference it by name like this, but you can actually also reference it by number. And we're going to see where this number comes in a second. We actually have to tell our project which levels to include. It's kind of strange. Why wouldn't it include all of them? But we still have to tell it which levels to include. All right, so that is our exit script. Actually, what I need to do is, instead of hard coding this, I should probably put a level settings here. And we'll call this destination spawn. And then also destination level. Okay, and then we'll use that here. So instead of saying cave, we'll actually call destination level, and we will call destination spawn. Hit save, and then let's fix my tooltip, make sure there's no syntax errors, hit save, and then now we can set this at the Unity level. So I think I have a little cube in there. So a little door that's kind of hiding back there. So I'm going to attach this activate exit onto there. And I'll rename this exit to cave. Not that it really matters, but at least it's exit to cave now. So the destination level is cave, and the destination spawn is called from overworld. And I'll put the underscore in there. Even though it is a string, I don't like having spaces in it. So that's what it's going to look for when we're going to the other map. And then we're going to want to drop a player spawn point here, because the player can come out of the cave and back to this world. And so this spawn might be called from underscore cave. And so now we have two spawn points. We'll call this cave, and we'll call this start. And our system that we set up is smart enough to know which one, that this is going to be when the game starts, this is when we're coming out of the cave. So now we can save this scene. We can go open up our cave, and we can rig this up now. So we need our spawn point. So we'll just plop a spawn in here. Make sure we're facing the right direction. That's a 90-degree rotation. And then this was called from underscore overworld. And then this door, I'm going to rename this exit to overworld, and I'm going to attach that script onto it, that activate exit script. And then so the map that it wants to go to, if we go look at our scenes, overworld was the name, and the spawn point was called from underscore capital C cave. And then we can save this. Now our maps should be linked because they're going to be writing into the game manager. So we're going to go back, because I don't want to start the game from here because there's no spawn. Like if I hit play. Oh, that's right. There's still that player object. So I'm going to take that player object out, and I'm going to hide the capsule on here. Hit save. Now we have to tell the project to include this level in my scenes. Now we're not spawning. That's correct. Okay, so I want to go to build settings this time. This is our first time to being in build settings. And you can see there's an option here to add open scenes. So if I hit that, it's going to include cave as one of the levels in my list of levels, and you can see that this is considered level 1, the overworld's considered level 0. So when I was showing you that you can do the scene manager.load scene command, you can specify it by number if you prefer, if there might be like a naming collision or something. So we will exit on that. We don't need to build it right now, that compiles it, so we just need to exit that. Then we go back to overworld, where the game manager originally is. Because it's going to spawn us in this player spawn point. like I said, there's no player right now. So we hit play. It's going to spawn us at the start. Then when we head over to here, well, I forgot to hide that capsule, but it doesn't have a collider, so we'll just walk right through it. And then we hit E. We load this level with my really bad lighting. And then when we hit E, ooh. We didn't set something up right on that. From underscore cave. Well, but it would actually just take us to, it would take us to a nothingness if that was the case. So actually what I suspect it might have been is the door might have been inside of the collider for the other thing. Possible. I'm going to make sure that the spawn point here from cave, that is correct. Running as fast as I can to the entrance here, go in, and then push E, come back. So yeah, it was stuck inside the collider for the other door. And now we're able to load scenes. We don't lose track of data. In the next video, we'll get a chance to see actually building a heads-up display where we can see our health, and then we can really verify that the information is being remembered between scenes. So this pretty much concludes everything I was going to do for Chapter 1. So in between the videos, I might clean up my island, hide some of these capsules, and flesh out my interior map so that I can have a space to put enemies and a space for me to begin attacking. So you might want to expand out that and start setting up some places where you think encounters will go, because Chapter 2 is going to give the player weapons and a HUD, and then Chapter 3, we will start implementing enemies for us to attack. So that concludes our first chapter of building an FPS in Unity. Some very big milestones. We've gone from scratch to being able to load different scenes and be able to remember information between them. So I might also include a part B to this, where I look at transitions where you just walk into them rather than activate them. But that may come up after I finish part 2 and 3. So thank you for watching. Stay tuned for the next chapter where we add some weapons and really start turning this into an FPS.